In order to make the apparently simple Little's theorem or Little's law more useful and attractive, we have to put it in real-world setting as a probabilistic relationship. In this module, we shall understand first what is time average, what is statistical or ensemble average, and how can these two be related to yield probabilistic interpretation in the light of Little's law. Again, the reference is Bertzicus and Gallagher. Let's look at the time average first. As the name implies, it is something averaged over time. It would involve a time scale and the measurements done over the time scale. The time average of a function is found to be evaluating a measure of a space, of a single space, with the average taken over, say, a time period delta t. It means we are interested in evaluating the average performance of a system within a given time. Mathematically, it could be represented as P sub n of t, that is, the number of customers within a system at time t established with a relationship of probability. So it means we are talking about the probability, the likelihood, or the chances of finding n number of customers in a system over a certain time period. Similar to time average, there is another concept called statistical average or ensemble average. In simple terms, we are interested that what kind of average behavior does the entire population of a system exhibit. It is defined as the number or a measure that determines the central tendency of a given set of numbers. It means we are not varying the time, instead we are varying the numbers for which we want to determine the average. It can be also interpreted as the simple average of given numbers. This ensemble average could be represented in different ways. For example, mean of a system, the median, mode, and the range. Now, it would be important to establish a relationship between the time average and the statistical average. It is here that Little's theorem provides us a great facility and support by making a simplified assumption. Little's theorem assumes that probabilistic interpretation of Little's law could be drawn by making a simplified assumption that the time average and ensemble average are interchangeable. It can be represented with the mathematical expression shown to you here. That is, on the right hand side, we vary the numbers, that is ensemble average, and on the left hand side we have the time average. It means if we equate the two, we are actually seeking a simplification, and this simplification is intuitively very powerful. What do we get? What we get is the increased application and power of Little's theorem, because now it is not only restricted to deterministic systems, it is also applicable to probabilistic systems. It was mathematically shown in various research papers that no situation exists where this theorem does not hold. That is why this theorem was raised or elevated to a level of a law.